Hello and welcome to TidyX episode 40. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes. Let's do this. All right, so the data that we're going to be looking at this week for the code that we'll be looking at in a second here is from the Tidy Tuesday project, and it is on BBC's list of 100 inspiring and influential women of 2020. So, all right, so this is highlighting women that are leading change and making a difference in these turbulent times. So thank you all, bottom of my heart, for all the work y'all have done. It's fantastic. So, but anyway, so we're going to jump into, there are a lot of great plots this week, but one really stuck out to both of us. Like we were kind of scrolling through looking at the various submissions, and this we're like, whoa, that one's really cool. So it is from Jackie Torres, and so this is an animation of the plot that she did generate, which is a sunburst plot. So I'll bring that up and try to make that, can I make it larger? No, I can't. Unfortunately, I can't make it larger. But yes, it's a sunburst plot, so you can, it shows the different categories that the top 100 women were classified into, and then it shows their names around it, and so you can kind of interact with it. She's also got cool tooltips on there. It's a lot of fun interactivity, and yeah, it's just like it's trying to do something different. So we both really like this. We reached out to Jackie. Hey, Jackie, mind if we were to explain this? She said, yeah, of course. So her code, she shared it right here in the link. It's on GitHub. So we went and copied this into our studio, and boom, here it is. And we're going to go through it now. Yeah, the syntax is different. It can be a little overwhelming, I think, when you're first coming at it, because their documentation doesn't necessarily list all the things, like on their website doesn't list all the things that you can possibly do. At least that's what I found. I could be wrong, but yeah, so I'm excited to go through this because this just like demonstrates the power of Plotly. So Jackie has her YAML header at the very beginning here. She's using the tidy template from Tidy Tuesday R. She has her setup chunk here at the beginning, so she's setting her options. She's loading tidyverse, Tidy Tuesday R. She's bringing in Plotly for an interactive sunburst chart and HTML widgets, so she can actually save the widget afterwards and then be able to send it out to folks. So I think that's a pretty cool piece too. She's loading in the data. Here, let's load that in before I get ahead of myself. She's loading in the data using ttload from Tidy Tuesday R. So load that in. It's pulling in the data set there. And if we quickly print that, get the README on the right there and the available data sets, which is the women data set. So she's pulling out that data set and assigning it here. And now she starts doing all her wrangling. So here she's got several different vectors that she's creating. And so this is data frame, she's calling it data frame 1 in this situation. She's prepping this. And this is like the high level view of the sunburst that you get to see. So she's got the labels all, creativity, identity, knowledge, and leadership, the number of number of people that fell into those categories there, what the parent to that label would be, and because this is the highest level, it doesn't have any parents, the IDs, which I think is then going to be used by Plotly, the images to be putting in there, the country, which is listed as various, the roles, which is various, the description of the field there, and then the colors to be using across the different categories. And she creates this first data frame here, where she's using data.frame to just join all these together. It'll by default use the name of the vector that you pass to it. So because so let's actually run all this. So now we have a data frame that has labels, and it's just using the name of the vector you put in there. One thing that I might suggest, because this you kind of have to know how you're building this out, one thing that I might suggest is using a tribble out of the Tibble package. So you can still do your df1 here, but then you use, I can type, zoom in, oh yeah, so there's tribble, and what you can do is you can type in labels, values, so as opposed to creating your vectors at the very beginning here, parents, I'm going to stop at IDs. I don't think you need me to type everything out. And then what you do is you just type in the value here. So this would be all. The next value is values, which is 1. Parents is empty, and IDs is all. And then you go on to your next row. That would be creativity, 21. No, there we go, 21. No parents, and IDs is all. Exactly. And so, I mean, I think this is, I didn't know about tribbles until I actually worked with the package data pasta, which is another really cool package that I suggest folks look into. We're not going to get into that right now. But so it just, to me, it's really visually easy to read and understand what's going on, because I know that when I'm building out data frames, or just using data frame and in vectors, I have to remember, okay, where am I entering all this? And this just makes it super easy to understand, and you can kind of format it so it looks nice too as you're building it. And I'll have an example in a little bit. So that's just a side comment there. Next, she takes the women data set. She does some renaming of the labels. So she's renaming name to labels to match the prior data frame she created. She's renaming category to parents. She's going to put the values of 1 because she wants each woman to have their own field in the sunburst. The IDs, she's going to concatenate, so paste together parents and labels. And so she's using paste, and then with the 2 spaces around here, I don't think you need to be doing that. You could do it like that, because paste is by default going to have a space in there. And so you don't need to, I don't think you need to be doing that. That's okay. Yeah, so there's lots of different ways to approach this. Then she's setting the colors here using a case when. So when the parents is all, setting it to be this hex code color, creativity to this hex code color, so she's telling the plot, or the plot she's going to be creating, these are the colors I want you to be using. Don't just choose a random set of colors. And then subsetting to keep only labels, values, parents, IDs, all these guys. So now she's got df1, which is a high level view, and then df2, which is this more detailed view. Then she's going to R-bind them together, which means she's going to be stacking them together, df1 on top, then df2. And she's creating this woman 2 data set here. And then she did this fun thing here. I think we talked about this in a couple episodes ago, the string R, string wrap, where she passes in the description of the achievement, and she splits it on a width of 100. So any time where the characters are greater than 100 wide, it splits it at the at a white space, so that it's no longer more than 100 characters. Yeah, essentially. Yeah, it puts a carriage return in there. So, and she's assigning that back to description 2. Boom. All right. So now she's done all her data wrangling. Now it hops into the actual plot. Patrick, you want to take us through this one? Right, because it's it's a data frame. IDs. Yeah. Yep. I think it's the actual label itself. So let's do head of. Did I not do this? Oh no, it's just I wasn't heading. So it's like the high level categories first, and then it's the actual woman. So that's the So the parents would be the highest, like, yeah. Mm-hmm. So yeah, so let's label. Actually, to me, this follows the better. Is it parents? Yes, there. Labels. So to me, this means like Hoda would be under creativity, but then creativity is the next level up in this label, and it doesn't have a parent, and so it's gonna like the plot is gonna figure out how it deals with that, but you're just kind of creating a dependency tree. Yeah, it's pretty sweet. Mm-hmm. Yeah, get more information. green. Yeah, exactly. Like layout is kind of like a lot of functions that exist in ggplot thrown into one. Like it's got like the label, the labs, it's got the theme, it's got, yeah, it's got like everything in there. It's insane how much stuff is in there. But all right, so let's build that and let's plot it. And here we go. Yep. All. A nice little tooltip. Yeah, whole bunch of stuff. I mean, you're basically doing HTML. Mm-hmm. Yeah, it's exactly. And just imagine how much work we would have had to just to create like this plot if we were doing it in ggplot. Like the number of lines that we would have had to write to get the bars to stack properly, and like the amount of data manipulation that we'd have to be doing. Exactly. So so much work. Mm-hmm. Yeah, and we'd have to like draw out the boxes, and then it figures out it'd be so much work. And here you're able to do it in 80, 15, 16 lines of code, and have this level of clarity. So this was great. Yeah. Let us know. Let us know if you want us to do that. Yeah, we want to do that, but tell us. Yeah. 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 Mm-hmm. For sure. That's like the main one. But yeah, so thank you so much, Jackie, for letting us go through and explain how your code worked to create this sunburst. And I'm looking forward to seeing what else you create in the future. And with that, we're going to hop over to, we're going to continue this thread along Plotly because we were interested in that. We thought that was a great way to start introducing people to Plotly. And so what we did is we went and we're like, what could we do that people might like? And so we thought, and we're like, you know what we could do? We could pull some baseball data. We haven't done baseball in a while. I feel like we've done soccer, a lot of basketball, but I feel like we've done baseball. I feel like we've done volleyball. Yeah, we did. Yeah. And maybe I feel like, yeah. I don't recall. I don't think we've done baseball. So this is baseball's time to shine, because baseball, I mean, everyone knows sabermetrics and like everyone's using, yeah, I mean All that. So there's a lot of stats that are collected around baseball. Lots of people get very excited around that. So we're gonna let me quickly restart my R session so there's no interruption between there. All right. So we've got the library. Thanks, babe. We're gonna bring in the library HTTR, which is a package from, of course, the Hadley Wickham. And it helps with API calls, which we'll get it. We're gonna glaze over that a little bit. JSON Lite also for dealing with the API calls. Tidyverse, of course, for dealing with any data manipulations we need to be doing, and Plotly to help us with our visualization. So I'm gonna go at a very high level with API interactions because you can spend a lot of time out there, and I am not an expert in this. I just know how to fudge around with it enough to get what I want, and then I kind of go. Anyway, moving on with my life. So where we're pulling this data from is from the baseballsavant.mlb.com website. So I'm assuming this is put on by MLB. This is at MLB.com. And so in order to get these calls together is I looked at the website itself and looked at the network that was going on there with the inspector that we do to normally figure out our RVest and our scraping with that. But this is written with JavaScript, so I can't quite do that. But there's some way it needs to be pulling the data in, and that's using these get calls inside of their JavaScript, but now I'm kind of doing it outside of it. And so I was inspecting the website, and I saw that in order to pull batter history information, it was sending to this website here, baseballsavant.mlb.com, player viz, lookup, player ID, had this series of numbers, and season equals 2020 or 2019 or whatever. So I'm like, oh, that's how it's pulling in this information. So if I go pull information, or if I send a GET request to that URL, it'll return to me a JSON with the information. And JSON is JavaScript object something. It is a common object in not R, and it's think of a list. It's to me, I think of it as a named list, where you can nest it insane amounts, and you can with a list. And so I think of JSON as basically a list here. And so I send a GET request to this URL. It returns a response. Either it succeeded and it's a class 200, or it failed and it's a 404, when you go and try to go to a website that doesn't exist. It's 404, it doesn't exist. So that's kind of what happens there. I pull out the content and I use JSON's parse JSON to turn it into a nice R object for me. Sorry, that is a very attempted to be quick crash course in API interaction. We're not gonna get too much more into that, but essentially what I'm doing is I'm going, hey website, give me your data, and it's going, yeah, sure. So that's kind of what's going on here, and then I'm letting tools that exist like parse JSON to turn it into a nice R object for me to handle it later on. So this is how you get the high level data, but then you need to know the player's UID, and you don't know that by default. So I wrote another function that would go and it would hit against their API again, but this time it sent a different query going, hey, I have this string that looks like a player's name. What is that player's user ID? And so that's what this piece of magic is happening here, is it's splitting it up and formatting the string so that it is, if I put in somebody's full name, it'll split it up. So it's last name, comma, first name, because that's how the query wanted it to be. I can't explain why. And then pulls in all the players that are named similar to that. And then it goes through a series of if-else statements to go, okay, if I didn't find a player named similar to that, throw an error going, I didn't find a player. If it's formatted in a way that I don't expect it to, throw an error so that I can actually deal with that later on. But if there's more than one player with that name, then it goes into this sequence here, where it creates a nice little prompt here. It's saying, hey, multiple players were returned. I don't know which one you wanted. I'll show you what it looks like in a sec here. It'll then go, hey, multiple players, and then it'll print out here's an ID, here's the player, and here's the player's user ID. Which one do you want me to pull? And then you enter in a number 1 through whatever number of players there are, and then it'll return you that player's information. So that's kind of what's going on here. Sorry, I'm kind of like jumping through this, but I don't think this is the important piece of the code here. And if you want to go, we can do more. Tell us if you want us to do more API interaction, and we can focus on one that's a little bit easier to grasp. So this is UID. I want to check to make sure that it's actually returning a value. So check, is it a numeric value? Because the UIDs are always fully numeric. Or if it isn't a numeric value, try to convert it into a numeric and make sure it didn't return an NA value. And then I'm suppressing the warnings. So I already know that if it fails, I don't care. I want it'll return false. Pull batter data. So here's all those functions that I wrote up ahead of time. This is kind of cleaning it up a little bit, where first it checks, I have the argument UID, which if I already knew the player's user ID, I could pass that. Otherwise, I pass their name. It'll do the player query for us. Go, hey, does this player exist? Yay, nay. If it does, it'll then return to me the UID. Otherwise, it goes through that sequence of decision making. It'll then get the batter JSON, which is a whole bunch of information about the player. I pull out their demographic information, which is a very high level information around the player themselves, and then the play-by-play in this data object here. And I return a list. Okay. Do you want to take us through this function here? Yeah. Yeah, it's going to make sure that I'm passing the correct argument here. So if I were to apply oogly boogly, here it'd go, no, that's wrong. Yeah. Yeah. A lot of manual labor went into that one. A lot of love. Yeah. Yep. Yeah. So here, let's actually kind of step through this a second. Classifier. Let's call group. So let's pull this out of here. So this is going to pull out this column here, right? And then this is going to pull out this column here. And then basically what I'm doing is creating a named vector of these. And then we're going to pass the name, the vector of the pitches that they received, but it falls under these names. And so now it's going to repeat itself. So if they got like a fastball, and I don't know. So they'd all return. Yeah. So like imagine this being a vector of like 200. then going to return that same order. It's kind of a weird situation here. I kind of cheated because I know R. So, like in the player play-by-play, we have a vector that's their pitch type, right? And that is all the pitches they receive, but it's always these abbreviated like FF, FA, FA. And so what I wanted, if I want to get this like more descriptive version of it, is I pass that vector of the pitches they received against this vector of like, okay, if the pitch is an FF, for defining that as a fastball. And so then it's going to return fastball. But because it's vectorized, because R is vectorized, I can have my class vector, which is just what the abbreviation is, and then what the value is that I want it to be returning. And because it's vectorized, I can pass just the list of FF, SF, and it'll return. Yes, and return that. Yeah, kind of. Sorry. This is, yeah, I realized when I wrote this, so this is kind of like really funky. I wasn't sure if it was useful or not, but yeah. It's hard to explain it though. Alrighty. Helps if I run everything. Oh, there we go. Yeah, we could have made it prettier and like had it return like a It's now got that for us. William Smith, position 2. Whatever that means. Yeah. And then we've got all this information about all the pitches he got thrown at him. So we're going to make this P by P, so play by play extra. So this is now going to be using our pitch classifier here that we created to get just a little bit more information about it that they didn't send us, like what group it is and the description of it. So here just so it's a little bit more explicit. And we will run that. So now I've got this play by play extra. We can have the pitch description, which wasn't there, and the pitch group. Just all the information there. So now we're going to throw it into Plotly. And so I tend to think of Plotly similarly to ggplot, and then I like to just add layers to it, or traces, which is similar to like the geomes, like the geom line and geom whatever. So I do Plotly, add trace. The mode is what type of layer I'm adding to it. In this case, I'm adding markers. The data I'm using is a play-by-play extra. The x-axis, because I wanted to make a plot of where was the ball when it was going over the plate, right? And so upon inspection of the play-by-play data, the two fields that did that were plate X and plate Z. Why they're named like that, I couldn't tell you. There's no plate Y. Well, because you already know where it's at. It's over the plate. And so I think x-axis is like the x-axis, side to side. Y is front back. And Z is up down. Which is strange. Like, to me, I don't think like that. I'm thinking that X and Y are around the plate, and then Z would be the in end. But this is how they defined it. Yeah. But yeah, so this is how you can create basically your own version of or an interactive version of ggplot's geom point. Mm-hmm. Somehow we have negative z-axes, which I don't. I mean, I'm assuming maybe the ball hit the ground before the plate, and they're just like trajectory would go here. I don't know. Yeah, I don't know. The API is not very well documented. Yeah. Take us through this one. So, if I remember my baseball days, typically it's the knees to the shoulders, and then above it's like where they define a strike zone is if the ball goes between your knees and your shoulders above home plate, that is the strike box. But of course, that's different for every player, so they just kind of normalize it for this. Where the way that I figured this out was I went on to Baseball Savant's website here, and I did the good old fashioned. All right, I can pull in. What was his name? So Smith Will, I believe it's this one. And I filtered down to go, okay, I got 2019. I'm going to look at their not curveballs, fastball. No, not fastballs. Off speed here, because this one gave me a really good point here that I could look at. I'm like, okay, so I know that I'm going to need a thing there to match it. And so I just basically like tried to match this, eyeballed it, and I figured that was close enough for our purposes. Actually, I did an inspection on this. I think I got a little overboard and carried away. Yeah. Oh, this is actually 2019. Realized I did that wrong there. So let's build that. And there we go. So let me zoom out a little bit so that there's less like RStudio stuff around it. And there we go. Yeah. I don't know, but Noah, like these are all the different pitches that Will Smith saw thrown at him. Mm-hmm. This is the off speed. So I think he is clearly a left. This is right-handed, a right-handed hitter. Because there's more balls being thrown over here that he's got to come after versus here, and here he gets hit by a pitch. Hit by a pitch. No, that's right-handed. This is the catcher's view, I think. Yeah, at least that's what was shown. Like, this matches Baseball Savant. And this, the way the view was, it looks like it's the catcher's view. Yeah. At least that's my logic. I don't know if it holds. But yeah, there you go. And so this is the strike box, and so there's a bunch of stuff like called strike that's just above. That doesn't have this many. There we go. They do. Yeah. Yeah, I thought it was fun to put together. I thought this data are really rich, and so I'm hoping that we can use this more in the future, because we only used like, what was this? 1, 2, 3, 4, 5, 6, like 10 out of the 180 fields that are available. So pretty nifty. But yeah, sweet. All right. Well, that was a lot of fun to take you out there. Hopefully, this gave you a little better idea of how Plotly works and how you can interact with that. Definitely go check out their website. They've got a lot more documentation and really good really good intro docs, really, to get you like started with using Plotly, and then it's kind of up to you to figure out how to get more advanced with it. But with that, I think we'll call it. Thank you for listening to TidyX episode 40. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes. Yeah. All right. Thank you so much, and keep on exploring your world.